So for our test that is either today, if you want it to be, or tomorrow, there's two kinds of factoring that you have to know. One kind is just the simple x squared minus 5x minus 6 kind of factoring. Let's just start with an easy one. Everybody try factoring that. And then there's the more complicated kind of factoring. But one thing at a time. If I wasn't feeling like I could factor, I wouldn't want to take this test. Because there's 2 or 3 problems that you're not going to pass then if you can't factor. Now, you realize we did have a whole test on factoring, so you're supposed to know how to do it. But I get it, you might just not be able to. Because it's hard. X and X. And then I teach my kids to do plus and a minus and think it through and see if this last number could come out negative. Would a positive number and a negative number be able to make a -6? Yeah, it would. So then I know I did my signs right. And then it's got to be, well, a lot of people start with 3 and 2 and then they realize that's not working. Because I'm getting 3x and -2x and that does not make -5x. So then they try to switch them around. It still doesn't work. And then you go, oh, crap, there's another way to make a 6. Instead of 3 times 2, it could be what? 6 times 1. There's 2 ways to make a 6. 1 times 6 or 3 times 2. Okay, so then it must be 6 and 1. If you're going to put the 6 in, I personally would put the 6 there and the 1 there. And then always check with these. 1x, -6x. Overall, that makes -5x. Yay, I factored it right. And then when they ask for solutions, do you get the solutions are what makes this part 0 and what makes this part 0? So if I say x plus 1 needs to equal 0, take away 1, x equals -1. You could have probably just thought that through. -1 plus 1 would make it 0. And x minus 6 equals 0, x equals 6. Cool. Those are your solutions. This was factoring. One more side note that is important for anybody taking the test today. What if this had been x to the third and 5x squared and 6x? Do you get they all have an extra x in them? And then you could have factored the x out and you would have had what we had. You get how they just all had an x in them? I'll make it red to make it really pop. There's an x here, there was an x here, and there's an x here. If they all have an x, you can factor it out. All right, next little review problem before we make the final decision on if you're ready. Do you remember how to do this? What if I put an x out here? Just an x. Do you remember how to do long divide? Okay, you put a number up top, and what do I tell you to always start with? X is correct. And you go x, does that work? X times x, x squared. I know it worked because it matches up, see? Then what do you do? Then you do the opposite thing. You remember how you make it the opposite? And now that goes away. And then you bring something down. And then you think to yourself, well, maybe if I put a 1 here, 1 times x makes 1x. Did that match up nice? No. Then I guess I needed a 3. And 3 times x will make 3x. Now is it matching up nice? Yes, it is. And you go opposite. Nothing left. Bring down the 4. Is there any way to put something here? No. So then that 4 is called the remainder. That was remainder 4. All right. And last but not least is the special kind that I called divide and conquer. See if you can factor this puppy. I like to think of it as if you can factor just the first part, Then you can separately factor the second part. Divide it, end up and conquer it by having it be easier to beat when you divide it in half. And I'm going to notice that those two both have an x plus 2 in them. That's the common factor now. And these things are what's left. And did you even look to see if this could factor more? Because I'm warning you, we usually make it so you have to factor it again. But this one, that doesn't factor. Let me show you one that would end not factored all the way. Well, first of all, who got this far? Raise your hand if you were good at that. Okay, good. And let's imagine a different problem, and you get to the end and it looks like this. X plus 6 and x squared minus 4. And then people are like, yay, I figured out that hard factoring problem, and then they get it wrong. Nora, why would we be wrong if we left it this way? Yeah, you can factor it again. And it'd be x plus 2 and x minus 2. Good. The x plus 6 was already factored. I'll bring it down, and there would be the final answer. Okay. So that's about as much as I can do before the test would start, because the people need the rest of the time for the test. Now, if you decide, I don't feel ready, I don't want to do this, then you don't have to. But then you have to tomorrow. Okay? If you take it now, the worst thing that can happen is you do bad on it, and then you've seen all the problems, and you had a good chance to practice, and then you can take a retake on it. You know what I mean? So if you're like flipping a coin, I'd lean towards taking it, because you can just always retake it. All right? So it's your life. You decide. Take it now, take it tomorrow. If you're taking it tomorrow, the only thing I ask is that anybody who's not taking it today, you have to walk up and ask me at least one question during the work time when everybody else is doing the test. If you're waiting to do the test, it's because you're not ready. And then that means you should be asking me a question. So during work time, you should definitely walk up and ask for help. Okay, that's my only deal. If you don't take it today, you got to walk up and ask me at least one thing during work time. Okay, that's all I have for the video for today. We're about to take that test for some kids that want to.